Okay, let's do minimum consecutive cards to pick up. In JavaScript, I used a hash map and a sliding window to solve this problem. I'll walk through it, and then this one's kind of hard to walk through and explain, so I want to actually use a debugger as well. One of the things that you see in this is this +1, and we have to do that because they want to know not just the difference between these, because normally you'd think, okay, the difference between these is, you know, there's only 3 cards to get the next, but they actually want the minimum number of consecutive cards you have to pick up to have to pair. So you have to include this inside of your calculation. So let's walk through this, and then we'll walk through it again. We are creating a map, and that's going to hold our values, and we have our right pointer here. As we're walking through this, we're going to walk through this while this right pointer is less than, so pretty standard there, so while it's less than the length, we're going to continue. So what we're going to do, we're going to build a map if the item doesn't exist. Okay, so cards right 3 doesn't exist in here. We're going to set the item in the map, and we're going to set its index right here. So our map's going to be built up of items and their indexes. Okay, otherwise, when we get through a point where we actually have a match, when we found a match, what we're going to do is go and we're going to get the difference here, and we're going to set it to the min. So we're going to set this is kind of a temp value, but it's also what we're going to end up returning, right? So we're going to say, okay, what's less, min currently or this temp value? And this temp value is, it's the index of the right pointer. It's the right pointer, sorry, it's the right pointer minus the value of where we found that first match in the pair. So where we found that, then we have to add 1 because, you know, 1, 2, 3, 4, not 1, 2, 3. And then we're going to set that in there. And then we move, this is the left pointer. This is the tricky part. This is the left pointer now. Then we reset that left pointer, we update it. So we have to set that, and that left pointer is only specific to the match in here. And remember to update the right pointer so we walk through it, and then we have to return -1 if we don't find anything. So if it hasn't changed, min equals infinity. If we get through this whole thing, we never find a match, we go, oh, okay, min is equal to infinity, return another -1. Otherwise, we just return min. So let's actually walk through this with breakpoint. Let's see if I can make this a little bit bigger. I don't see where that is. We won't worry about it. So let's walk through this. And with the play button, and right now we've initialized everything. We're just starting our loop. And we're going to set, because it does nothing's in here. We haven't found cards right, which is 3. And then we're going to increment right. So we're going to do this until we find the match. And when we find the match, should be right about here, I think. Yep. So when we find our match, we have now matched our cards, because map has 3. It has found this key in here, and we are returning the value of this when we get cards right. So when we get cards right, that is 0. So if we step over this, you can see temp is 4 because 3 minus, well, let me do this. 3 minus 0 is 3, and then we got to add 1, because you remember 1, 2, 3, 4, not 1, 2, 3. That's what they want. So set it. Set min, update min here with whatever's less, because there will be other pairs in here, and we're trying to find the minimum number of consecutive cards. Then we reset this pointer here. So we're going to update our left pointer, our value inside of our map. So remember 3 right here, this is the index that we found 3 at. Now the next index, we've updated the value in our map to be the new index of 3. This is a horrible example because we have 3 and then we have the index of 3, and the pair of 3 and the index of 3 makes this very confusing. So I wish that somebody hadn't written this like this. Very confusing. Anyway, then what we're going to do is we're going to increase our right pointer, and we're going to go through the loop again. And we'll look to see if we find, with the same pattern, do we find anything that's less. And actually right now we're going to find one, we're going to find the 4 pattern, or sorry, the 4 pairs, the 4s. So this pair right here, and it's the same. So again, to walk through this one more time, our right pointer was incremented from 3 to 4. We are going to get where it found cards right. Cards right here is the key, and it's going to return the value. What is the value of this? It's 1. That's right here. And then because of 1, 2, 3, we have to actually add that count in. So our plus 1, we'll check against min, and then from there we set cards right with we'll update basically the left pointer. 0, 1, 2, 3, 4. See, again, this is dumb. This is so dumb. But you can see how this is now the left pointer in here, and as of right now, it's showing our key right here of 4. This is the item, was found at index 1. So now it's going to say, all right, we're updating. We last saw 4 at index, you guessed it, 0, 1, 2, 3, 4. So dumb. Increment right, and we can just continue through this all the way till it spits out our result, which is 4. So I will leave you here with that. Let me see if I can get this correct again. If you're having trouble understanding how this is working, feel free to just change these to 30, 40, 20, 30, 40, 70 or something like that. Sometimes that helps me. And definitely, if you're walking through this and it's not quite making sense, use some breakpoints, walk through it. Hope this helps. I'll leave this here.